So in this example, we're asked to determine what is the total moment produced by the force F um, uh, that's applied to the tree um, that that force would cause about the base of the tree that's defined at our origin point here. So in order to do this, so to figure out what is our moment at point O, we know it's going to be equal to the cross product of R and some force. All right. In this problem, our force we could define um, is the force that goes from point A to uh, point B. All right. All right. And then the position vector we can define in two points. We could either define it from the origin point to point A, or we could define it from the origin point to point B. Okay, so you can either ROA, or you could define it from RO from point O to point B. So either of those are going to would be option or be fair to use. We're going to use this option. We're going to use the position vector from point O to point A in this example problem, but you could definitely do position vector from point O to point B. So we're going to define. We have to first define ROA and R and FAB first as Cartesian vectors. Then we can take their cross product. So for FAB, we know that's going to be equal to the magnitude of FAB. All right, which was given in the problem as 2 kilonewtons here times the unit vector that goes from point A to point B. All right. So 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 to save some time here, I included this calculation of our position vector from point A to point B, which is just equal to position vector A minus position vector B minus position vector A divided by the magnitude of RB minus R of A. So if you evaluate all that out, what you'd end up getting is this would be your Cartesian force, your force vector as a Cartesian vector, and then ROA would be equal to RA minus RO. RO is the unit vector to the origin, which is going to be equal to 0. So it just ends up getting is equal to RA, which is equal to just 12 times the unit vector k. Okay, so what we can now do is we can take our cross product to determine our moment. So we can say MO is equal to ROA cross FAB. Alright, we can use our determinant formula to calculate the cross product of any two Cartesian vectors. So we're just going to copy those in. So we'll get 0. So for ROA, it would just be equal to 0, 0, and 12 meters. For FAB, you would get 0.4588 kilonewtons. In X, we would get 1.376 kilonewtons. In Y, and we get minus 1.376 kilonewtons in J. So the first thing we'll do is we'll copy our first two rows here. So our columns. So we would get you would just copy the first two columns of our matrix over here. So once we do that, what we'll end up getting is we're going to get we're going to multiply along our diagonals from the top left to the bottom right. What we notice here is that the position vector has a lot of zero terms in it, so it's going to make our calculations pretty simple at the very end of it. So if we look at just our positive diagonals first, or diagonals that go from the top left to the bottom right, what we'll see here is we'll get the first term is going to be equal to 0. So I cross times 0 times minus 1.76 kilonewtons is going to be equal to 0. J, if we multiply the second diagonal, we'll get 12 meters times 0.4588 kilonewtons, and that's going to get multiplied by the unit vector J. So we would get 0.4588 kilonewtons times 12 meters. All right, and then the last one we would get 0 times 1.376 kilonewtons, which is also going to be 0 here. All right, so then the next step is going to be looking at the right, the diagonals go from the top right of our matrix to the bottom left. So we're going to start off with the first diagonal, which is the unit vector k times 0 times 4.588 kilonewtons, so that's going to be 0. Our second unit vector is the unit vector I times 12 meters times 1.376 kilonewtons, so we have to remember we have to add a negative sign to that product, so we'll get 12 meters times 1.376 kilonewtons. And then the last thing we'll get is 0 times 1.376 kilonewtons, which is just going to be equal to 0. Alright, so if you do that, if we multiply everything out, our final moment is going to be equal to minus 16.512 kilonewton meters along the x-axis. The y-axis will be equal to 5.5056 kilonewton meters times y, or times j, and then there'll be no coordinate along the z-axis. So if we round these terms, what we end up getting is minus 16.5 kilonewton meters along the x-axis, and we'll get 5.51 kilonewton meters along the y-axis. All right, and that's our result for a Cartesian vector about a point using our 3D cross product formula.